Okay, this lesson is going to be talking about different forms of linear functions. Hopefully it will help you make some more sense of some of the sequence things that we have been doing here most recently. Also notice that we are covering a handful of sections in this book, but we're not going to actually be doing all of those 5 sections. We're just going to kind of be talking about different parts. So let's go ahead and take a few notes. There are 3 forms of linear functions. Standard form is the first one, and that is written ax plus by equals c. It is really good for finding intercepts, the x and y intercept if you have both. And another note that you need to take here is that in standard form, a, b, and c all have to be whole numbers. So one of the things that we think about standard form that you kind of need to commit to memory is that x and y are on the same side and there are no fractions in standard form. All right, slope-intercept form is the y equals mx plus b, which you all are already familiar with. Remember, in slope-intercept form, we want to name a few things. First of all, b is going to be the y-intercept, which you all know is written in the format 0, y. M is our slope, which is like our rise over run that you need to know. And then the y and the x, see, we've never actually talked about this before. I don't know if you've ever heard this anywhere, but xy, so you may want to write this down, xy is a point on the line. And we'll kind of look at what that means here a little bit later. More often than not, slope-intercept form is going to be the one that you are most familiar with and you're going to use the most. All right, the next one is point-slope form. And to be honest, I used to not teach point-slope form, but now I think it's actually more helpful than some of the other formats. And it's really going to be the one that we use kind of more often to begin with. So just so you know about point-slope form, you should recognize M is important. And it actually still stands for slope. All right, this is called point-slope form for a reason. So that's the slope, just like it was in slope-intercept form. And then this gives you a point on the line, which we call x and y. So this x1, y1 is actually a point on the line. So an equation in point-slope form, just so you kind of see like where the numbers would go, since you're not as familiar with this one, might be like y minus 3 equals 2x minus or plus 5, all right? This is an example of something in point-slope form. What I want you to notice or make a note of about this point is that this point is given to you opposite in the equation. Okay, so I'm gonna show you kind of what I mean by that and just show you the information that each of these gives us. So this first example says, what do equations tell you? And it's important for you to know, because we're going to be dealing with all these different forms. When you see an equation, what information do you know right away? So for instance, this first example here, 3x minus 5y equals 20, that's in standard form. And right away, without having to do too much work at all, I can see the intercepts. If I look at the x here, I know that the x-intercept, if I divide that, is going to be 10. So I'll write that 10, 0. And then if I look at the y values there with the other one, I know that the y-intercept, that's going to be negative 5y equals 30. So the y-intercept is going to be negative 6. So I'll write that 0, negative 6. All right, this next equation is written in slope-intercept form. So I know that the slope is negative 4 and that the y-intercept is negative 3. So I'll write that 0, negative 3 because it's a y-intercept. All right, this last one is the one that you're not as familiar with. This is that point-slope form. So the slope is 2, because we said, right, the m goes in front of the parentheses there. So my slope is 2. And I know that these other 2 points make up an ordered pair. And when we write an ordered pair, it's x, y. So I know that this is going to give me a point on the line. It's written as an ordered pair, x, y, and it's opposite of the way the equation gives it. So notice this first, the x value here says negative 4. So the opposite of negative 4 is positive 4. The y value here is positive 8. So the opposite is going to be negative 8. All right, you see how that gives you that information? So we'll practice a few like that in class tomorrow. All right, so just so you have a chance to connect this to kind of the sequence stuff that we've been talking about already, I'm going to show you 3 more examples of this in the sequence format, and I'm going to do these kind of out of order. So the first one is this recursive one that is back here at the very end, and you all know that that just means that the first term or the starting point is -4. And another way to write that is that the first point is -4. That's like giving you an ordered pair to think about it. And then we also know that the rate or the rule is going to be to add 9 every time. Okay, this middle equation, so this middle equation should make you think about slope-intercept form. So that means that my starting value is going to be at 5, and since it's like a starting value in slope-intercept form, that means the 0 value is 5, or the 0 term is 5, and that the rate, or the slope, or however you want to talk about that, I guess I should write one of those words, right? The rate or the slope is going to be -3. All right, now this last equation, I hope is going to make you think about this point-slope form. So if I kind of move back and think about that, the multiplier is going to be the slope, just the same way the multiplier is the slope or the rate in point-slope form. So here we can say that the slope or the rate is going to be 3, right? The same way that it was in your point-slope form up here on this last example. And then remember that this inside is supposed to make us think opposite. So that's going to be that the fourth term is -8. All right, so, and we'll talk about we'll talk about kind of some of this again tomorrow, but hopefully that's going to build some more connections for you as to how all of these different forms work. All right, we have one more thing to do, and that is going to be talking about changing between different forms. So there are going to be times when certain forms are more helpful, even though you might start in a certain place. So this first example says changing to slope-intercept form. So that means whatever I have, I want my final equation to be in the format y equals mx plus b. So to me, I realize that means y needs to be by itself. I also recognize from this equation that I've been given that I don't need any parentheses. So that's the first thing I'm going to do is get rid of those parentheses. And to do that, I'm going to distribute. So that's going to give me y plus 4 equals -3x plus 6. And then again, notice all I want is y by itself. So the only thing I have left to do is subtract 4. Now sometimes you may not be sure like where to subtract the 4 from right away, but notice I've got a -3x and a +6, and I can't subtract 4 from anything with an x because it doesn't have an x. So that's going to give me a final equation of y equals -3x plus 2. And there is a similar, not even similar, equivalent equation that is still the exact same line, it's just written in a different format. Okay, and this last example, changing to standard form. So remember, standard form is going to look like ax plus by equals c. So x and y are on the same side, and the only other rule is that a, b, and c all have to be whole numbers. So I'm still going to start in the same place that I did on the last problem. I'm going to distribute first. And that is going to give me y minus 5 equals 2 over 3x plus, remember when you multiply fractions, it's the top that multiplies, so that's plus 24 over 3. Now, one thing you want to do, if you can, is to simplify anything that simplifies. So I noticed that 24 over 3 simplifies, so I'm going to change this to y minus 5 equals 2 over 3x plus 8. Now, I know, again, with standard form, right, like I said, I have to have whole numbers, so I'm going to get rid of the fractions by multiplying every single term by 3. Make sure you multiply every single one. That's going to give you 3y minus 15 equals 2x plus 24. And then I just need x and y on the same side, so I'm going to need to move this 2x to the left. And when I move that over, it's going to subtract it. So that's -2x plus 3y minus 15 equals 24. And then the only last thing I have to do is to move the 15 over, which is going to be to add 15 to the other side. And so my final equation is going to be negative 2x plus 3y equals, if I add, let's see, 39. Now, there is one little catch here, and I am okay with you leaving this in standard form. Some books say that in standard form you can't have a negative in the front. So another equation that would be equivalent to this would just be to change all the signs or multiply or divide by -1, which would give you 2x minus 3y equals negative 39. Again, I'm okay with you leaving it this first way, but I just wanted to show you that that is also an equivalent expression.